5.9, simplifying complex numbers. They're going to spend a couple days on this, so this notes page will have 2 days worth of notes on it. So you're going to use this twice for your videos. What is a complex number? A complex number is typically written in the form of a plus bi. Okay, and that I is the imaginary part of the number. So right now you don't know anything about imaginary numbers. So this is the first time you've seen this. And whenever you use the letter I in math, it means you have an imaginary number. And there's really only 2 things you need to remember. The square root of a -1 is the letter I. I squared is equal to -1. So if you know those 2 things, you can do any of the problems. So we'll start off with the pretty easy ones. Now, we used to say that the square root of a -49 would be no solution. And we no longer will say that because we will have learned about these complex numbers. So we're not going to say it has no solution. We would say that that's the square root of -1 times the square root of 49. And the square root of -1 is I, and 49 is 7, so the answer is 7I. So this negative underneath the radical gives you an I, and then you just do the number as you always have. So the square root of -100, well, the square root of 100 is 10, and the square root of a negative is I, so 10I. Now, if it's not a perfect square number, you just break it down the way we always have. We would have the square root of 4 and the square root of 5, so we would have 2. They'll put the I right here, 2I root 5. So 2 root 5 is the 20, and the negative is the I. Now they're always going to put this in front of the radical. So we don't want to write that as 2 root 5I because it's hard for me to tell if you think the I belongs under the radical sign or outside of the radical sign. So let's make sure we write our answers as 2I root 5. The root should always go last. Okay, so with simplifying them, not too much work. I is treated just like any other letter, okay? So if you have 4I times 2I, you would have 8I squared. But what we want to remember is I squared is equal to -1. So that's 8 times -1, which is -8. Number 5. The square root of -5 times the square root of 10. 5 and 6 get missed the most. All right, make yourself a note. Don't multiply first. All right, make sure you don't multiply first. What you want to do is take care of the I stuff first. So this would be I root 5 times root 10. So you want to move the i's out front before you multiply them. Now you can multiply them if you want, or you could say, wait a second, that's root 5 root 2. So I know 5's can get out, so I have 5I root 2. So whichever way you like to break down your radicals, you can do that. But it's important you get the I out first. If you don't, you'll get number 6 wrong. This would be I root 5 times I root 20, which is I squared root 100. That's -1 times 10, which is -10. If you multiply these together first, you'll get a positive 100, and you would get positive 10. So you have to get those i's out of there before you multiply. Number 7. When there's letters, same thing as you would do before, except you got to get this I out of here. So this would be I root 9 root 3. So I would have a 3 come out. So I'm going to have 3I. And then root 3 is left underneath. Do the letters. 2 goes into 3 once with 1 left over. So the only thing different in these problems is the negative sign, and you got to get that out. Now remember, these are only in square roots. We already know how to do the cube roots when they're negative. These are only square roots. All right, how do you simplify I to the 10th? There's a couple ways to think about it. Remember, the only thing we know is I squared. So wouldn't you agree that that's I squared times I squared times I squared 5 times? Because we would add these all together and get 10. Okay, now that can be a long process the bigger this number gets. So let's think about that. We have I squared 5 times. 2 times 5 is 10. So you want to try to break it down so you look at an I squared. The reason why you want to do that is, what is I squared? It's negative 1. So we have negative 1 to the 5th power. Well, negative 1 times negative 1 times negative 1 times negative 1 times negative 1 is negative 1. An odd number of negatives. An odd number of negatives is still negative. Now I don't want to write down 10 of these over here. So I'm going to do it with my exponents instead. I would have I squared 10 times. 2 times 10 is 20. That would be negative 1 10 times. And even number of negatives when you're multiplying would be positive 1. All right, do it one more time. 33. Well, now, wait a second. 2 doesn't go in there. That's okay. 2 goes into 33 16 times. 2 times 16 is 32, and you have an extra one out here. That would make 33 I's. So here's 32 I's, 33 I's. So this one is an odd one, so you'll have an odd guy out. Do the same thing. That's negative 1 16 times. An even number of negatives is a positive, so it's 1 I, or simply I. So your answers for these type of problems, 8, 9, and 10, are either going to be 1, negative 1, I, or you might get negative I too. Just depends on how the problem is set up. Number 11. Multiply. 4 times 3 is 12, times negative 2 is negative 24. Then I would have I to the third. Well, I to the third has an I squared in it. You always got to get the I squares out of there. So you might break that down to I squared I. I squared is negative 1. Negative 24 times negative 20, or negative 1, is positive 24I. So you can never have anything in your answer except for a single I, because you got to get your I squared simplified. Number 12, that would be 25I squared. I squared is negative 1, so negative 25. All right, you also have to be able to add, subtract, multiply with I. It's no different. It's just a letter. This is an addition problem, so we're going to add like terms. So 2 and negative 1 is 1, and positive 3I and negative 7I is negative 4I. So 1 minus 4I. Now they'll always write the answers with the I at the end. Remember, it's A plus BI is your standard form. If there's a negative, well, I change it to positive, negative, positive. Add like terms, I would get negative 1 plus I. So it's just adding and subtracting. Now we got multiplying. So we have FOIL. It's no different than normal foiling. 2 times 3 is 6. Outside is 8I. Inside is minus 3I. And last is negative 4I squared. I squared is negative 1. So this becomes positive 4, because when you multiply a negative 1 times a 4, you get a positive 4. 6 plus 4 is 10. 8 minus 3 is 5i. Number 16, we should remember the pattern. Square the first one. Multiply them and multiply them by 2. 4 times negative 2 is negative 8 times 2 is negative 16i. And then square the last term. That would be plus 4i squared. Plus 4i squared is really negative 4 because this is negative 1 and that changes the sign. So we got 16 minus 4, 12 minus 16i. We're going to do a lot of foiling with these problems, so you got to be good at foiling. Number 17 is a no middle. We should recognize that. So we just need to do first and last. 16 minus 25i squared. Negative 25i squared becomes positive 25 because that's negative 1. 16 plus 25 is 41. So you can see that no middle problems get rid of the I, which of course we're going to use when we use conjugates. And now they'll mix radicals and imaginary numbers together. Remember, you got to get the i's out before you can multiply. So it's 2 minus I root 3 times 2 plus I root 3. Now again, this is a no middle. So first and last. First is 4 minus I squared times 3, because root 3 times root 3 is 3, minus I squared root 3 is really plus 3, because that's negative 1 times 3. Take the opposite of that. 4 plus 3 is 7. Again, you were able to get rid of the i's with this no middle and the radicals. So again, that's a conjugate, so you're getting rid of the things that you don't want. So that's all for day 1. You'll open this back up to finish for day 2 in tomorrow's video.